You're looking at something humanity was never supposed to see, the closest images of the sun ever captured. Blistering light, violent eruptions, and streams of charged particles, all unfolding just millions of miles from the heart of our solar system. But this isn't just a pretty picture. On Christmas Eve 2024, NASA's Parker Solar Probe did the unthinkable. It didn't just orbit the sun. It dove straight into it. At a mind-bending speed of 430,000 miles per hour. That's fast enough to circle Earth more than 17 times in a single hour. Parker became the fastest human-made object in history. But even more astonishing, it got closer to the sun than anything ever built by us. So close that, if the Earth and the sun were just 1 foot apart, Parker would have skimmed within half an inch. But the story doesn't stop there. For the first time ever, Parker's instruments captured what it saw inside the sun's outer atmosphere. And what it revealed could rewrite everything we thought we knew about our star. To understand how groundbreaking this mission is, you need to know just how extreme Parker's journey has been. It's not just the speed. Though 430,000 miles per hour is faster than anything we've ever launched into space. It's the proximity. In December 2024, Parker flew just 3.88 million miles from the sun's surface. That may sound like a lot, until you realize the sun is 93 million miles from Earth. Put it like this. If the sun and Earth were scaled down to just 1 foot apart, Parker would have plunged to within half an inch of the star's surface. Half an inch from a roaring nuclear furnace over 1 million times the size of Earth. No spacecraft has ever come that close. And to survive it, Parker relied on some of the most advanced heat shielding and engineering ever created. But it didn't just survive. It observed. And what it captured wasn't just heat and light. It was movement, structure, activity, a window into a realm we've only ever seen from afar. And this is where the real story begins, with the first ever images of solar wind captured not from Earth, but from inside the sun's own atmosphere. For decades, scientists have tried to study the solar wind, that constant stream of charged particles blasting out from the sun. But we've only ever seen it from a distance. Until now, as Parker plunged through the outer atmosphere, it gave us something we've never had before, a front row seat. Using an onboard instrument called WSPR, short for Wide Field Imager for Solar Probe, it recorded the solar wind right at the source. Not from Earth, not from orbit, from inside the sun's own atmosphere. WISPR doesn't stare directly at the sun. Instead, it captures the faint, visible light bouncing off particles as they explode away from the corona, the sun's outermost layer. And those images? They're astonishing. They show solar material in motion. Bright arcs of plasma, ghostly waves of particles, bursts of energy moving with purpose and violence. For the first time, we're seeing the solar wind not as a distant concept, but as a physical, churning force right at the sun's edge. And this changes everything. Because once you see where the solar wind begins, you can start to see how it behaves, how it interacts, and how it might threaten life here on Earth. But before we get to that, we need to understand something fundamental. What does it actually mean to say Parker touched the sun? You've probably heard the phrase, Parker touched the sun. But that raises a strange question. How can something touch the sun if it's still millions of miles away? Well, to answer that, you first have to forget everything you know about the sun. Unlike Earth, the sun doesn't have a solid surface. It's not a glowing ball of fire with a clear edge. It's a swirling, chaotic sphere of superheated plasma, a state of matter so energetic that atoms break apart into a sea of charged particles. What we usually see as the sun's surface is actually the photosphere, a glowing layer of gas dense enough to emit visible light. But even that isn't solid. It's more like a fuzzy boundary, where light escapes into space. Above it lies the corona, the sun's outer atmosphere, and it doesn't stop at any sharp line. It just gets thinner and more diffuse the farther out you go. So when Parker entered the corona, it wasn't brushing past it. It was flying through the sun's actual material. Every second, it was surrounded by solar plasma, weaving through charged particles and magnetic fields erupting outward into space. In that moment, Parker wasn't just watching the sun. It was inside it. And that's where it made its next groundbreaking observation, capturing something scientists had only ever imagined until now: the raw, unfiltered birth of the solar wind. So what exactly is the solar wind? And why are scientists so obsessed with it? In simple terms, it's a constant stream of high-energy particles, mostly electrons and protons, blasting out from the sun's corona at incredible speeds. But this isn't just solar weather. These particles carry the sun's magnetic field with them, and as they race outward, they form a giant protective bubble around our entire solar system. It's called the Heliosphere, and without it, we'd be in serious trouble. Think of it like an invisible force field, shielding the planets from dangerous cosmic radiation that comes from deep space. Without the Heliosphere, Earth would be exposed to a storm of high-energy particles that could damage our atmosphere, our satellites, and even our DNA. This is why Parker's observations are so important. By capturing the solar wind at its origin, inside the corona, we're finally able to see how it forms, how it accelerates, and how it behaves in those first critical moments after it leaves the sun. And as Parker sent back its first images, scientists noticed something strange. In the middle of all that flowing solar wind, something massive was coming. Among the streams of solar wind, Parker captured something far more dramatic, something scientists had only ever simulated in models. A violent, real-time collision of three massive solar eruptions, known as coronal mass ejections, or CMEs. Each CME is like a solar explosion, a colossal burst of plasma and magnetic field hurled into space from the sun's outer atmosphere. But these weren't just isolated events. They erupted in rapid succession, and then they collided. When CMEs interact like this, the result isn't just a bigger wave. It's a whole new phenomenon, a merged superstorm called a cannibal CME. As one CME overtakes another, they combine into a single, more powerful burst of solar energy. Why does this matter? Because these aren't just space fireworks. When a cannibal CME barrels toward Earth, it can supercharge the effects of space weather, turning a typical solar storm into a potentially planet-wide disruption. Parker didn't just witness this once. It saw the full chain reaction unfold, from eruption to collision to acceleration, offering scientists the clearest view yet of how solar storms become more than the sum of their parts. The Parker Solar Probe isn't just a marvel of engineering. It's a mission that's changing how we see our own star. For the first time, we're not studying the sun from a safe distance. We're flying through its atmosphere, witnessing its storms, and uncovering the mechanics of a cosmic force that shapes every second of life on Earth. From cannibal CMEs to magnetic switchbacks, Parker is revealing that the sun is far more dynamic and far more dangerous than we ever imagined. And with each pass, it's taking us deeper into the unknown.